Okay, thank you for your patience watching 3 videos today. I hope to make this last one a short one. So part 2 of this activity for the day is the shortest of them. What you will find is that we have our parameters, which you already know about here for M and B. You've already learned how to plot the residuals. So the other thing we're going to look at are these statistics. So we have our R value, which is sometimes called the correlation coefficient, and our R squared value. And I've explained on the worksheet a little bit in the highlighted portion about what these mean, so you can hear it in my words, and I'm going to say the same thing in writing, so hopefully it makes sense after both. So here we have an R value of 0.37. What this tells us is a strong correlation would be something closer to 1. A weak correlation is something closer to 0. It's a positive number, which tells us it's a positive correlation. And we know this because the correlation is in the upward direction. But the R value here tells us that this is a not particularly strong correlation. We would call this a weak correlation, meaning that the forearm and the height are not particularly strongly correlated. There's a lot of variation in the length of people's arms and their height. They aren't necessarily a good predictor of each other, and that's explained by this number. Now, the R squared value is literally what you get when you square 0.37, you get 0.14. And they're kind of just two different ways of looking at the same thing, and I'm no expert in statistics. But what the R squared value tells us is percentage. So 0.14 is 14%. And what it means is our line of best fit, our least square residual line, is not a very good model because the line only explains 14% of the variation of this data. The rest of it, 86%, cannot be explained by our model, and therefore our model is probably not a very useful tool. What you generally look for in a model that you would like to trust would be something closer to 90 or even 95% of the variation is explained by the model, which would tell you that it would be a good model to predict other inputs and outputs. But nonetheless, we do have these numbers, and at least we know what they mean. So what I'm looking for from you today is, regardless of whether we have a strong or weak correlation, to be able to use these numbers to explain what kind of correlation we have, and using these numbers to explain why you know that. So hopefully this helped, and we will end this video.